Now everything we've seen so far, while all well and good, it could have been done on a calculator. But now we're going to go into things that really use the power of computers. And what computers are good at is doing boring, repetitive calculations over and over and over again. So let's say we think of our calculation of orbital speeds. Let's say you didn't just want that at one altitude, but at a whole range of altitudes, a whole table of it. Okay, so let's get that going. We're going to modify the existing program. Normally it's good practice, don't write a new program from scratch, modify one you've already got. So if we go to this tab here, showing us our list of files, we can see the ball height calculation one is still running, and the orbit speed calculator is not running. So if we click on that, it will start it running again. Now because it's been shut down and restarted since we last saw it, we're going to have to press Shift Enter in all the cells again. It's forgotten that it did imported maths, it's forgotten what these variables meant. If, for example, we tried this cell over here, right now, it doesn't know what any of these things are because we haven't run this cell first. So, start at the beginning, let's run that one, then run this one, and now this should work. Yep. But now we're going to replace the cell with one that actually prints out a whole table of speeds at different radii. Let's put it down here actually. So what we're going to use is something that's called a loop. A loop is a construct you have in most programming languages that allows you to do a bunch of commands over and over again a certain number of times. We're going to use a while loop. This is probably the most common type. It keeps doing something until a condition is met. So it could be you keep eating chocolate until stomach is full, or keep walking until you hit the wall, or keep doing physics homework until physics homework is finished, something like that. What we're going to do, first of all, we're going to have to start our table somewhere. So let's start at the Earth's surface. So we'll start with r equals 6,400 kilometers. And we're going to work at the step. So let's step up in maybe 100 kilometer increments. So each row of our table will be 100 kilometers. So let's call that, I don't know, step perhaps, and that's 100 kilometers. And we're going to have to work at when to end. So let's call that end, say, and it doesn't actually matter what you call it. You can call it zog, ziggy, and poo-poo if you liked. The program doesn't know that step is a word in the English language. It's just a bunch of 4 letters that now refers to space in memory. Let's go out to 20,000 kilometers out. That'll be the end of our table. Okay. Now let's use the loop. Now the loop command is while. So start off by saying while. That indicates it's going to keep doing what's in the loop until a condition is met. Now we need to put the condition. What we're going to do is we're going to say we'll keep going as long as the radius is less than our ending point. So it's r less than end. And then you also put a colon at the end of these while statements. So that means what's going to follow this command will be done over and over again until r is no longer, the radius is no longer less than end. So that's kind of what the end means. It's going to stop there. Now you'll see after I hit return here, it's come to one tab in. The commands inside the loop are all put in usually by one tab, or it could be a certain number of spaces. It doesn't matter as long as it's consistent. And that's our way of telling those things are in the loop, they will be done over and over again. So let's calculate the velocity. So we'll copy this line from over here. Copy and paste. Now we need to update r. So our table is going to start off with r is 6,400 kilometers, but now we want it to go up by 100 kilometers. So what we're going to do is r, we use the plus equals command. That means take what it was before and add, in this case, a step. So it's going to add step to whatever r was before. And now we need to print our table. So let's print, and just do r equals, comma, R V equals comma V. Okay, so because all these three lines are indented by the same amount, Python will regard them as being part of the loop. So what it will do is it'll start here, set r equals 6,400 kilometers, set the step, set the end. Then when it gets to this line, it says, I'm going to have to keep doing this until this condition is no longer met. So then it'll do all these things. Then it'll go back here and check, is the condition met? And if it's still met, it will do them all again, and again, and again, and again. Okay, let's see if it works. Shift Enter. Okay, well that's given us a table. So we've got the R value and the V value, and quite a lot of them. This will take a long time to calculate on a calculator. And it's done it. So that's the use of a loop. It allows you to do calculations over and over again really fast. Now loops can be a little dangerous. There are some things that can go wrong. Let me show you the most common thing that goes wrong, which is not realizing what's inside and outside of the loop. Remember, everything that's indented, that is, got this tab in front of it, is inside the loop. But let's say the print command wasn't inside the loop. Let's say it was down like that. Now, I've written exactly the same things here, but now if you run that, we're going to get a very different response. So what's happened here? Well, the print command is now not part of the loop. So all it's done is it's printed the end value. So what happens is it starts off here with R, this value. It calculates V and the new R. But then print is not in part of the loop. So it then jumps straight back to the while and does this again. So it's doing those two lines over and over and over again until the condition is no longer met, at which point it jumps out of the loop and then does the next command, the print command. So the print command is only done once at the end, not all the way through. So what we really want is, let's put a tab in front of that, bring that back inside the loop. So it's a very common mistake not to realize what's inside and outside and use the space as a marker. Now that's one common mistake. There is another common thing that goes wrong which can be much nastier. Let's say we'd left this line out. Or let's say we'd set step to be negative. Or something like that. What I'm going to do is I'm going to not quite delete this, I'm going to put a hash in front of it. If a hash is in front of something, that's telling Python ignore everything else in that line. It's actually used for comments. So what that now means is ignoring that line. Now what's going to happen now? R is not going to update. So it'll calculate V, R will not change, it'll print, and then it'll calculate V again. It'll do this over and over again. But because R is not getting bigger, this condition will stay true forever. R is going to stay at 6,400 kilometers. It's never going to get more than 20,000. So this will run forever. So we've now got a program that will never stop. Now with some tentativeness, let me actually try running that. It's going, 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 and it's going, and it's printing the same thing over and over again. It's never going to stop. We're now in an infinite loop, as it's called. And the program is running, 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 and will never stop. So you can't really do anything else very much. What we have to do is go up to this kernel button here and restart. Okay, so now we can fix that. We can bring this thing back. Because you've restarted, it's forgotten everything we have up here, so we have to shift enter on all the lines again. And now it's just done a nice finite table that finishes. So if you ever get yourself in trouble, you've got a loop that's going to go forever because you put something wrong inside, so it never meets the end condition, then go up here to kernel, restart or interrupt, and that will fix it for you.